Hello, this is Eileen, the environmental educator, and in this video, we're going to talk about something that's gonna, they say, take care of beach erosion, and $50 billion is planned to save Louisiana's coast. And I've done some videos recently about the houses that fall into the oceans and beach erosion, where they did $500,000 worth of replacing sand that get washed out in one storm, and this is just becoming a process that is costing huge amounts of money. And right now, somebody came up with a solution that they're going to create natural cement. Scientists electrocute sand to stop coastline erosion. This is MSN. Today's August 22nd. That's when this article came out. It says that erosion has become a constant threat, eroding beaches, damaging infrastructure, and costing billions of dollars each year. And they project that 26% of the world's beaches may disappear by the end of the century. And this article even has a little video, and they talk about a house that got knocked off of a cliff in North Carolina, which I did videos about. It was on the beach, and it's happening other places too. And there is, regardless of the independent media will tell you that global warming is not real, there's no problem. Coastal erosion is a problem, and it's proven by the massive amounts of money that people are spending to try to save beaches from all of the storms that are eroding them. But right here, researchers at Northwestern University have developed a new sustainable solution to tackle the issue. They told Interesting Engineering that the lack of sustainable and efficient approaches to mitigate coastal erosions spurred the study. So they said they were inspired by natural processes used by clams and mussels to build their shells. They have developed a method to strengthen marine coastlines. This method applies a gentle electric current to marine soils. The researchers are optimistic that this approach could provide long-lasting, affordable, and friendly solution for reinforcing coastlines, is how they put it. They say that clams and mussels use dissolved minerals in seawater to form their strong shells. Likewise, researchers use naturally existing dissolved minerals to form a natural cement between seawater-soaked sand grains. They use this electrical energy to kickstart the chemical process. And what happens here is they say seawater is naturally rich in a variety of ions and dissolved minerals. Therefore, a moderate electrical current, 2 to 3 volt, can cause chemical reactions in seawater. The electricity has the capacity to transform some of its ingredients into solid calcium carbonate, the same material used to make mollusk shells. With a higher voltage, 4 volts, these constituents can be turned into magnesium hydroxide or hydromagnesite, a common mineral found in various stones. In the presence of sand, these minerals come together and hold the sand particles together. So this is what they're proposing. They said that by applying a mild electric simulation to marine soils, they systematically and mechanistically proved that it is possible to cement them by turning naturally dissolved minerals in seawaters into solid mineral binders, a natural cement. This means that the sand transformed in those grainy, loose particles to rock-like and movable solid. Together, it could form a strong seawall, safeguarding coastlines and properties for decades. And they showcased this process. The team showcased that this process proved to be effective with various types of sand, ranging from common silica and calcareous calcareous sands to iron sands. There you go. There's some sand there. Sample of strengthened sand treated with mild electricity. So they added electricity to this sand there, and you get strengthened sand. They said that there is no risk to harm sea life as the voltages used in the process are too low to be felt. By modulating the applied electrical currents, it is possible to achieve minimal impacts on the environment. They said notably, approaches leveraging the same mineralization process have been used for decades to grow artificial coral reefs in various marine regions around the world, and evidence proves that the use of mild electrical simulations in seawaters does not affect marine life. No animals will be harmed in this. They also say that it is reversible. Now, they don't say how it's reversible, but they just added that in there. They say this innovative approach to more sustainable and cost-effective alternatives to traditional methods like building seawalls or injecting cement into the ground. And they estimate that the cost of electricity cementing 1 cubic meter of ground ranges from $3 to $6. The next step of this research consists delving deeper into a number of fundamental scientific questions and at the same time commence the scale up of this technology. So they're looking to move this forward. They're going to electrify sand to change it into solidified sand and prevent coastal erosion and protect all of those beach homes that are falling into the ocean. So we'll see how this turns out. Stay tuned, people.